Hey everyone, this is Matt with Learn Everything About Design, and in this video, we've got quite a lot to cover. So if you're here for the electronics library content, then take a look at the chapters. You can go ahead and jump forward and you can skip kind of this informational section in the beginning. But note that this is a bonus video from our game controller design series on learneverythingaboutdesign.com. That is a series that walks through the process of designing a game controller from start to finish. So we go through the electronics picking and breadboarding and programming and the design of the PCB in Fusion. And we also design the housing in Fusion as well. So if you're interested in that content, this video that you're going to be watching is sort of a bonus video from that on setting up your own components in an electronics library. You won't be able to follow along with everything because the end of the video, we talk about repairing components in a downloaded library. And that's when they're missing things like 3D packages. So you'll be able to watch it and you'll be able to get some tips from it, but you won't have the data sets because those come with the course and they're things that we do and develop as part of the course. So just keep that in mind. The end of that video is not going to be, you won't be able to follow it, but you can follow that first part. So if you want to stick around, I'm going to be talking about a lot of different things in the start of this video, which is going to make it kind of long, but there are going to be chapters. So we're going to be talking about the learneverythingaboutdesign.com website. We're going to be talking a little bit about merch. We're going to talk about some of the things that we have going on with the channel and some of our planned projects. So you can kind of get an idea of where the channel is going and what we plan on doing. So first things first, the course content. So last year we set up learneverythingaboutdesign.com, and that was a way for us to build and sell courses. Now, part of the reason for that is because putting course content on YouTube is hard to advertise, for one. It pops up in Google search very well, but the problem is we are kind of at the mercy of the algorithm. So if we don't want to try to game the system with doing things like clickbaity titles or the thumbnails being very clickbaity, that kind of stuff really helps user engagement, but it doesn't really get to the core of the audience that we're trying to serve. And that's the people that are trying to learn, not really be entertained. So because of that, and because of the fact that ads are on these videos, no matter if we monetize them or not, we felt that it was better to develop our own website and have our course content there. Now, the YouTube channel is still going to have all the how-to content. We're still going to be putting videos up here on the regular. That's not going to change. But anytime we develop a new series, so for example, we've got the Porsche 911 and the Ferrari 308 series for 10 plus hours of video where you're going through an entire process of modeling a car. That type of content is going to start to be developed for the lead website now. Again, the reason for that is partially because of things like advertisers. We don't really have good control over over what happens with that. I can turn on and off things like mid-roll ads, which does affect how much money we make on videos, which isn't much if I'm honest, but the ads are still going to be there no matter what. And I don't really have control over that. And I don't have control over the revenue that comes in from those ads. So putting that onto our own website gives us a little bit more control. It also allows us to swap videos out or add more videos to course content. So the reason that's important is because software changes. Now, I have put videos on YouTube for the past couple years now, at least 2 years, and some of the older content is starting to be out of date. Now, unfortunately, it's still getting served up. I still get comments on it, and there's still plenty of views that happen on those 1, 2, 3-year-old videos. And the problem with that is we don't have control over updating that content. If I go in and pull that video down and replace it with a new video, it's not seen the same in the eyes of the algorithm. Part of the reason is because the comments and the thumbs up and all that stuff, that's not tied to the new video anymore. So it just makes that process a bit more complex when we're trying to develop educational content. Now, if it's entertainment based, that's a different story. That's not as big of a deal. But if it's like a video in the middle of a series, that's a bit more of a problem. The other thing is it allows us to have a bit more control over the community. Of course, YouTube has community options where people can buy in and do subscriptions and so on. I don't really love that model for this channel. So the lead website allows us to do those kinds of things, to offer things like coaching or bundling course content together. We can open up forums and we can have better engagement with the community. We're still building the site out and we're still figuring out how all that works, but that's the intent, is to have more of a community that allows us to interact with people rather than having to go through the video comments and then having people email me and so on. So we're trying to build toward that website as sort of the main source of course content, but still keep the YouTube channel and sort of explore different content ideas there. Which brings me to the next topic, and that's the YouTube channel. So right now it's mainly how-to videos. I answer a lot of questions in videos, so sometimes the content doesn't make as much sense, but what we do is we take comments or emails from users. They're having a problem with the design, and I try to answer that. If I'm not able to answer it easily in an email, sometimes I'll make a video response for it. So there's a lot of content like that, and I think that's a good way for people to learn. But also we have Surface Mastery series, we have the Forms Mastery series, where we're just kind of adding videos as maybe the software develops or maybe a new topic comes up. So we've got a long list of videos to do for those series and for other things. So that content will still keep growing for Fusion, for SolidWorks, for Plasticity, for Blender. So as we get to it, those will still grow. We will be doing promotional content, so similar to this video here, where we are putting a video that's part of a course that we're selling, or we'll do like a promo video for a course or a course bundle series. So that kind of content will be here as well. And I'll try to make sure that things like the thumbnails and those things are tagged differently, so it's very understandable. And the third type of content that we're going to be doing is more entertainment based. So going more in the style of looking at a design problem or project. So we're going to be resurrecting some of my old projects. We're going to be doing a motorcycle build series for one, and then we'll kind of see where it goes from there. Now, those series will not have how-to videos, but they'll be more showing the entire side of the process of designing a certain component for a project. And then at the very end, we'll do, like a sort of a sizzle reel, if you will, of the project itself. So we're going to be exploring that kind of content. We're still working on that. I've got a lot of parts here, and we're getting more equipment in to do some of that. Part of the reason this is complicated is because with the business side of things, so our business side is actually Caducation. Myself and the other party, the editor, videographer part of this process, we used to live very close together, and past couple years we've kind of moved several states apart, so it makes things like filming live content a bit harder. So we're just kind of working that part of it out. We want to make sure that the content we put out is has high quality. So we're not going to be releasing any of that content yet until we sort all those different pieces out. Still working on cleaning the garage setup up and getting better lighting in there and sort of those kinds of things. So that content is coming, but those are the big three changes that will happen on the YouTube channel. And also the merch store. So we did launch a merch store, of course, because why not? But we want to do it a little bit different. So we do have shirts and mugs and all the normal stuff that you would see on most merch stores, but we did release the first sort of flagship product, which was the desk mat. The reason that this is a flagship product is because the idea behind the merch store is not just to flood you with things with the logo on it, but it's to give you products that will actually be helpful. So the desk mat represents the first product in that line with the Fusion shortcuts all around it. Now, it's not every single shortcut. So we don't have like, Control S for save and those kinds of things on there. But it is all of the design shortcuts, and it's separated by the sort of the common ones on the left side, and then the workspaces around the rest of the desk mat. So there are two variations of that. One with the Camaro that was sort of the original tutorial I did at this point 14, 15 years ago. That was a car that I modeled and did a tutorial in SolidWorks for. So that was kind of the product that, or the tutorial that sort of launched me into this direction of making educational content rather than just doing design and consultation work. So that is on one of the desk mats, and then there's the sort of grid background to the Fusion UI. That's in the middle of the other one if you don't want the car model in the middle. So those are the first products in those lines. We do have a couple of other products in the works that I'm not going to mention quite yet, but we will be releasing additional products that will be in sort of that same nature, where they have a value, sort of a value add product, not just a shirt or a sticker or a mug. But we do have those things as well, because people like that kind of stuff. So all that stuff is there as well. So I think that covers everything that's going on with the channel, with the website, with the merch store. If there are any comments or questions, I know that I get quite a few emails, and I try to respond to everybody. It is hard because some responses take a bit more time than others, and the YouTube channel, the Learn Everything About Design website, the merch store, it's not my full-time job. So I do try my best to get back to you. If for some reason you're waiting on a response for more than a week from me, then please just reply back to me again. You won't hurt my feelings if you're reaching back out, but just note that I do get quite a few requests and emails and things like that. So I don't necessarily, I'm not avoiding anybody. I just don't get to all of them, unfortunately. So just keep that in mind. And I think that is it. So with all of that said, which took a bit more time than I expected, we're going to go ahead and hop into this video for the game controller design course, where we talk about setting up and building an electronics library. So thanks everybody for watching. I appreciate everybody that has subscribed to the channel and liked and commented on the videos. I like hearing from everybody on kind of what they're building and doing. I've gotten to meet a lot of very, very interesting people that have interesting projects, and I love seeing that. So definitely keep them coming, keep the emails coming, and let me know what you're working on or what you're having problems with, and I'll do my best to try to help. All right, so hopefully you've made it through the course and everything went smooth, but I know that there are plenty more things to this topic that people are going to want to know and learn how to do whenever you're making your own circuit board designs. The one big piece of information that was left out of this course really deals with creating your own library components and fixing connections to things like a 3D package for a design. Now, in the library that was provided with the course, we omitted those 3D packages for a few different reasons. One is because when you are looking for a component in a library, oftentimes they're going to be missing. Whenever a new component is created, you can make the 2D schematic and the PCB layout, and then you just can simply omit the 3D package, and then you'll get some sort of rectangular block that ends up on your circuit board. Now, for most people, if you're not diving into 3D design based on the circuit board, that's perfectly fine, and you don't need to go through the trouble of making a 3D package. However, if we're designing 3D components, like in this case, a housing for our circuit board, then we certainly want to go through the process of making sure we know how to make those 3D components. So what we're going to be doing in this bonus video here is we're going to talk about building our own components from scratch in the library, but we also want to talk about how we can fix those missing pieces of our design. Now, with the data set for this specific lesson, there is going to be a couple of 3D models that are provided. A tactile switch, which is a 6mm push button, the QT Py, and a 512, which is the joystick. Now, these models were all downloaded, the QT Py models downloaded directly from Adafruit. The tactile switch and the joystick were downloaded from suppliers through DigiKey. So what we're going to be doing in this case is we're going to show how we can connect the dots between those components in our library, but we're also going to show you how to make your own from scratch. Because this is a big topic, this video might get a little bit lengthy. So we're going to start from the basics to learn how to create your own. We can see how to use that, and then we'll go back and we'll fix and reconnect those different pieces, because it's going to be important we understand how everything connects. So to get started, inside of your project in your data panel, we're going to begin by finding where you saved your team, in this case, your team library, and we're going to double click on that. What this will do is it'll open up our library and allow us to begin editing. Inside of the library, we only have three things. We've got our joystick, our momentary switch, and the QT Py. And inside of here, if we expand these, each of them will have something underneath. Underneath this, we've got what's called the symbol. And the symbol is going to be what we use on our schematic layout. And then below that, we have what is going to be the footprint for the PCB. Now, if it's a through hole, it's going to contain all of those holes and the copper pads around them. If it's a surface mounted component, it'll have the pads that go on top of the board. Now, this is going to be true for pretty much everything you find in the library. Some things are going to have symbols for a schematic like ground and power that do not need anything for the PCB. They don't need anything in a 3D model. But for the most part, when you're looking through a library, this is what you're going to see. Not everything has to have a 3D model, and in some cases, you're going to find just this rectangular block because that's created by default. So what we want to do in this video is get started understanding how we can create our own item in the library, build out not only the schematic that we need for the symbol, but also the pads that we need for a PCB and the 3D model itself. So to get started, the first thing we want to do is come up to New Component. Now, the new component that we're going to be creating is going to be a surface-mounted push button. So I'm going to give it a part number PTS810, and then we're going to hop over to a web browser and we're going to look at DigiKey. Inside of this lesson, we do have a link to the PDF for this. This is going to be important. And most of the time, whenever you find a component on DigiKey or Mouser or some other website, it has a link to a PDF datasheet. In some cases, you might find a 3D model here. You might find a manufacturer's website link. It really is going to depend on the specific component. Some components will have 3D models easily available, some will not. You just have to sort of look around at what's available to you. Now, in this case, there is not a 3D model, but it's a relatively simple part. And the main reason I want to use this is because the data sheet is going to highlight the schematic. It's going to highlight the pad layout that we want for the PCB. And it's going to give us all the general dimensions that we're going to need to just build a basic representation of this in 3D. So make sure that you do have this PDF open if you want to try to do this on your own. I'm going to be dragging it over to another screen, and I'm going to be using that as a reference. So what we're going to be doing is starting with this PTS810. Now, what we've created so far is just going to be a new component. A component is a container. The container can have a symbol for our schematic, it can have the footprint for our PCB, and it can have what's called a package, the 3D model. We need to start building each of those pieces and then connect them together. So we're going to create a new symbol. For the symbol, I'm going to be using PTS810. Again, I'm going to use that same name across the board. Now, it is important to note if you're creating something like a push button and there are many different configurations that may use the same symbol, but you might have a different footprint or package, then you can sort of nest those under everything. But we're only working on one single iteration of a component. When we come in here, the first thing that we want to note in the top center is the units. Now, the units are important because most of the time you're going to find the spec sheets are going to be in metric units. We want to make sure we understand when we're looking at these, those units are important, and we want to make sure that at least when we're drawing things out, whether it's for the symbol, which isn't really as critical, or it's for the footprint for the PCB, that we understand those units. Again, the symbol is not really that critical, but just keep in mind that those units are, in this case, it's shown as inches, and then you can kind of see the grid here is 0.1 inch. Now, if we go to our grid settings, we can change this to metric. So you can simply move over and put it at metric. 2.54 is going to be the standard grid spacing, and that's going to work perfectly fine for us. So again, I'm going to just drag this over real quick so we can see it. This is going to be the schematic that we're building. So that's exactly what we need to create right here. Now, the main point of this is to be able to build our circuit inside of that schematic. So we're going to start by simply drawing it with lines. It doesn't have to be perfect, but what I'm going to do is I'm going to simply start over here, 2 grids up and 2 grids to the left, and I'm going to go 2 grids up and 2 grids to the right and say done. Now, that's my first line there. I can copy that line, but what I'm going to do is just create another one down here. And that is going to represent pin 1 and 2 and 3 and 4. Now, the symbol that happens in the middle is important. We're going to change the bend type here. We're going to start to come up, and then I'm going to just kind of come over at an angle. So that's going to represent the switch portion. And then I'll just do one more line, and this one I'll bring down here. And then I'm going to add a circle, just a small circle here. And that way it looks or represents a switch. Now you can play around with the grid spacing and we can move these lines around after we create them if we want to. That's perfectly fine, but just note there are some limitations to things like the angles of some of these lines. Not a huge deal, but right now all we have is a drawing. We have lines. But with a component, we need to be able to connect it together. And the way that we do that under place is called adding a pin. Now, not every component will need a pin, but a lot of components will. The first thing that we want to do is note that if I place a pin, it's going to have this long section on it. That's fine if you want to sort of stagger it out here. For this example, I'm going to set the length to the smallest section, which is basically 0, and I'm going to place it here. I'm going to place another one here. So 1, 2, 3, and 4, and say done. Next, I want to select these and rotate them. You can do this a couple different ways, but we're going to use rotate, and I'm just going to sort of work my way around. I'm going to click it and put it on the left-hand side. I want to do the same thing to this one. Now, the main reason for that is just to have things look a little bit cleaner. By default, it's going to come in as $$1 and $2. These are default names that are given to pins, pin 1, 2, 3, and 4. If you want to change those, all you need to do is select this, come over to the properties of the pin, and we can give it whatever name we want. So for example, I can set this one as 1, I can set this one as 2, set this one as 3, and then set this one as 4. For example, if we were making the schematic, the symbol for the cutie pie, we could draw the box, have some text on there that really doesn't matter. It's just for us to see. And then we can add all the extra details for the number of pins that we want to connect to, for example. So this is the basic symbol. That's all we need. We're going to do a quick save. And now we want to build what is actually going to be put on our circuit board. Now, there are a couple of ways to do this. I do want to mention that. We can use what's called the package generator. And this is a little tricky because you essentially are skipping the footprint step and going straight to 3D. But when we do this, if we use the package generator, there are a lot of things already in here. So for example, if we were making an axial type of resistor, we can use all of these standard pieces here, the information about the footprint and manufacturing data, and this would generate a 3D package. And it would also generate all the information that's needed at the 2D level when you place it on your circuit board. This isn't really what we're going to be doing. Now, you could cheat the system a little bit by coming in here and using this DFN-4, setting it as like an IC or a resistor or something else, and build out the 3D package that's pretty close to our push button switch. But just note that it's probably helpful to look through here and find if you already have a 3D component in this package generator that you can use. If you're doing something standard like surface mounted chips for things like voltage regulators, all that stuff is pretty much in here. So look through here first before you spend the time to model something. For us, that is really going to be more of a hack. So I'm going to say don't save, and I'm going to build it from scratch. So to build it from scratch, all we need to do is select new footprint. Again, I'm going to use the same PTS 810 because the footprint, the schematic symbol, as well as the 3D package can all have the same name because they're essentially different file types or different data. That's fine, but you can't have that same name if it's going to be multiple versions of it. It has to have a different name. So for example, when we have the tactile switches, these are all going to have slightly different naming conventions. Even though they're variations of the same thing, a 6mm and a 12mm and so on, the naming convention is very similar, but it does have a unique ID. So once again, when we get in here, we want to double check our grid settings. Grid settings are going to be important. They might default to inch, they might default to mil or mic, kind of depends on your settings. Most of the time you'll find that the schematic, The symbol for the schematic is going to be in inches by default for some reason. And when you come in here to do the footprint for the PCB, it's going to be in mils. I'm not really sure why that is, but that's just the case. So this is actually pretty straightforward. If we go to the place dropdown, we've got options for an SMD pad, so surface mount, which is what we're doing here, PTH, which is a through hole like the other things that we had on our board. And then you can also use those for arrays here. There's some other stuff for drawing text if we need to add bolt holes and things for the PCB and patterns and so on. So for us, we're going to be using this SMD pad, but note that you do have an array option. We're not going to be using the array option here. The next thing that we want to do is take a look at some of these default sizes. You might find when you're looking at, actually I'm going to hit escape on this and bring this back over. You might find when you get a recommended PCB layout that it doesn't give you the data exactly how you need it to model it. Now, what I mean by that is when we start to type in locations for these pads, we're going to be typing in the center point location, and the distances here are going to be to the extents of the pad. So we have to do a little bit of math and subtract these values out. So for example, to figure out where the center location of this is, we're going to do 5.2 millimeters minus 3.1. That's going to give us the difference, which is the distance or the width of both pads together. So then we'll divide that by 2. And now we know that each of these pads is 1.05 wide. And in order to get the center location, we simply take that and add it back to 3.1. The reason that works is because we know the pad width. And basically what we're doing is we're taking 3.1 and we're adding half to this side and half to this side. So now we know its total distance is 4.15 to get to those centers. And then if we divide that by 2, that gives us the distance from the origin, the center of it, out to the left-hand side. We just do the same thing over here, and we end up with 1.075 in the vertical direction and 2.075 in the horizontal direction. Now, you might find that when you actually get into the software here and you start to add a pad, that the recommended pad size isn't available. You can see here 1.016 is pretty close. I tend to err on the side of caution and make them slightly bigger instead of slightly smaller, especially if you're going to be manually soldering these yourself, then having a slightly larger pad is helpful. But just keep in mind that especially with things like push buttons, the location of those push buttons is important, so you don't want them to float around too much. To get started, I'm just going to place 4 pads. And the reason for that is now I'm going to go back and edit them. The origin or the 0 location is here, and you can tell by moving your cursor around. You can see that when you move your cursor around right there, it's about 0. Currently, we're at minus 2.52 and positive 2.52. That's pretty much 2.54. It's just because the cursor can float around a little bit. And all we need to do is select this. I'm going to give it the name 1. It can be $1. That's perfectly fine. And then I want to put its location. Now remember that was minus 2.075 and positive 1.075. We'll do the same thing over here. This time it's going to be positive 2.075 in the X direction, 1.075 in Y. I'm going to rename this to pin 2. We'll see why in just a little bit. And then again, minus 2.075. This one will be minus 1.075 in this quadrant. This is going to be pin 3. And the reason that's pin 3 is that's based on the specs. And then this one will be pin 4, 2.075 and minus 1.075. So again, if we bring this back, when we look at this, pin 1, 2, 3, and 4, we want to keep that in mind because the schematic, the pins on the schematic and the pads that we're putting on the PCB layout, the footprint, we need to connect those in the software so it knows when we're doing the air wires and we're routing things on the circuit board, it needs to know where those things are. So now that we have these and we have the numbers associated with them, these are all on the top layer. They can be flipped to the bottom layer when we're actually laying out our circuit board, but basically what this means is these will be placed on the top layer of our circuit board. The next thing that we want to do here is we want to add some text, some notes, maybe some silkscreen lines. These can be on various different layers. Layer 21 is typically the place you would add this. And then we're just going to grab the line tool. And I'm just going to add a horizontal line here. And I'll repeat that as well underneath. And the main reason for this is you can just add a border or some sort of placeholder for where the switch is going to go. These can be moved around as well. So currently it's in the 2.54 in the Y direction. And if I set this to, let's say, 2.127 and 2.127 here, basically what I'm doing is I'm bringing that Y coordinate down. This would be minus 2.127 minus 2.127 here. Basically, we're just moving it a little bit off of where the snap points are on our grid. The other thing that we can do while we're still on that layer is we can add some text. So for example, if we wanted text on here for pin 1, we want to make this a bit smaller, maybe 0.60, and we can decide where we want to put that. I'm going to do pin 2, put one over here. We'll do pin 3, put it down here, and pin 4 over there. You can obviously take some time and put these wherever you want and organize this, but this is the basic premise of creating this. Now, there are obviously going to be more things that you can do. As I already mentioned, through holes and arrays, as well as adding holes, things that you may add to the board, and a pattern. You can do this if you want to create, for example, a proto space on a board. You can create a bunch of these through holes or these holes and just make sure that you add them to your board appropriately. The next step in this process, quickly, we're going to save it. But the next step in this process is for us to create a 3D package. Now, as I already mentioned, you can use the package generator, which will actually backtrack itself and build the footprint for you. So again, if there is a 3D component in there, you can use that functionality. For us, what we want to do is we want to manually build a 3D version of that push button. And the reason I think that's important is because most of the libraries will have everything that you need to build a circuit board. You generally don't need to go in and do something simple like a push button. In most cases, you can find that. But I have noticed that there are some times when you need to generate your own model. It doesn't need to be perfectly accurate. It's not a manufacturer's level of detail for the part that you're adding. You just need enough that you can design around it. So when we use the 3 dots on the right-hand side, we have an option called Create New 3D Model, but we can also attach a copy of an existing 3D model. So if there is a 3D model that exists in your library that you want to use here, then you can add it. We are going to create a new 3D model. Again, I'm going to use that same name. And notice that when we're in this package generator area, it brings in a couple of things. It's going to bring in the text that we have. It's going to bring in the lines that we added on our silk screen, and it's going to bring in an outline of those paths. When it actually builds this in 3D, it will bring a couple of extra bits over. The main thing that we want to concern ourselves with at this point is navigating to solids, starting a new sketch, and building out a basic 3D model of our push button. So for this, I'm going to start a 2-point rectangle or a center point rectangle. The overall height or orientation here is 3.2 millimeters. The overall width is 4.6. And you can double check yourself. If you bring the diagram over, you can see those pads stick out just a little bit. The overall width of the design is actually 4.2. So what I'm going to do is just edit this. It's parametric. I can come back and I can change this at any point. We're going to just make that 4.2 and make sure everything looks okay. Once again, it doesn't have to be perfect, but we're going to extrude this up. This is going to be a total height of 1.8 millimeters. We'll start a new sketch on the top. This time we'll go to Create Slot. We use Center Point and begin dragging this out. And then using our Dimension tool, the overall width of the push button, again, by looking at the diagram, is 2.2 millimeters. The overall width in that direction is going to be 3 millimeters, which is the outside edge of the rounded sections. So what I'm going to do is 3 millimeters minus 2.2. And the main reason for that is because what we're doing is we're taking away the radius from this side and the radius from this side, which we know is 2.2. 2.2 is the diameter, so the radius is 1.1, and that will give us 1.1 on one side, 1.1 on the other, and then to get to our 3 millimeters, that's going to give us 0.8. Then we can extrude this. The overall height of our device is 2.5. Then we can subtract out the 1.8 millimeters, and we can add a small fillet to the top. And now we've made a basic 3D package. You can come in here and you can add as much or as little detail as you want. If you want to round the corners a little bit, and we want to repeat that, maybe add a small fillet here. You can, of course, come back and do that, change anything you want. But when you're done, all we need to do is just a quick save, just to be sure. And when we select finish, it'll push this back into our library. So essentially what we've done is when we go back to our footprints, now we have a drop down here. So we got our footprint and we've got the 3D package. So we're not quite done yet, but let's do a quick save on the library. Anytime you see the asterisk next to anything in here, whether it's the symbol, whether it's the footprint or the 3D package, just basically means that something is unsafe. But now we need to go back to the original components because this PTS 810 does not have anything associated with it. Remember, this is a container. We built out the schematic, we built out our footprint and the 3D package, but now we need to tell it that all those things go together. So once we have this selected, the first thing that we're going to do is we're going to come down and select new and add local package. We can select PTS 810. This is automatically going to bring in our footprint as well as bring in our 3D package, and we can say OK. From here, we need to add the symbol. Now, the way that we do that is under device, we have add, and then we can pick the symbol that we generated. Now, part of the reason for this is because symbols are a lot of times going to be universal. A symbol for a switch is fairly universal, whether it's a surface mounted switch or a through hole, whether it's 6 millimeter or 12 millimeter or 10 millimeter. It really doesn't matter because functionally they are the same. So the only thing that really matters is that we attach this together. So at this point, we've got a symbol, we've got our footprint, and we've got our 3D package. But you can see there is a little yellow triangle here under mapped. And the main reason that's there is because we need to connect our pins. So what we want to do is connect pin 1 inside of our schematic, the symbol that we're going to use on the schematic, with pin 1 or pad 1 on our footprint. So we'll select connect, and we're going to do this making sure that it goes 1 to 1, 2 to 2, 3 to 3, and 4 to 4. And then we can say OK. Now that those are mapped, basically what we have is a connection between pin 1 on our schematic and pad 1 on our footprint. So that means pin 1 and 2 are automatically connected. Pin 3 and 4 are automatically connected based on our symbol. And when we go to build this out, then what's going to end up happening is it will be able to connect things together. There is one other important bit of this that I do want to mention. And for that, we're going to go over to our symbols and we'll come to this symbol here. The 0 that's designated next to here is considered a swap level. Now, if 0 is there, that means the pins are not able to be swapped. If we want the pins to be interchangeable, because pins 1 and 2 are connected across the board, pins 3 and 4 are connected, what we want to do is give them both the same swap level. So pin 1 and pin 2 will have swap level 1, and down here, pin 3, I'm going to do swap level 2, pin 4, swap level 2. And essentially what this means is in the software, if I am building out my schematic and I connect pin 1 and pin 3 to the in and out of my switch, or if I connect pin 2 and pin 3, it knows that pin 1 and pin 2 are interchangeable. So when we go to that circuit board layout and we're using our footprint, it understands that those two pins are interchangeable because of the way the device is created. Not all devices will be like that. If you're setting up a microcontroller symbol, for example, like the QT Py symbol, these are all going to be swap level 0. Some of them are set as input outputs. You can see we've got power These are all set as specific pins. If we select them, there is options to change things as inputs only or outputs only, for example. So keep in mind that there are some variations here, but if you do need those pins to be interchangeable, you can use that swap level. If you ever have any questions, then it's always a good idea to start by going into your learning and product documentation, navigate to the electronics section, and find information on that specific topic. But that's a basic idea behind swap levels, is being able to interchange those pins. So going back to our library, we now have 4 things in here. We've got the joystick, the momentary switch, and we've got our new push button and the cutie pie symbol. To test this out, I'm going to go to a new design and simply create a new electronics design. We'll create a new schematic. This is going to allow us to drag that symbol in. You can see that it's got 1, 1, 2, 2, 3, 3, 4, 4. That's everything that we put on there. It's going to give us information about those pins. Then if we go and push this into a PCB, what we're going to do is I'm just going to drag this down to make the PCB a bit smaller. And I'm going to drag this onto the center of it. Now, what we have here is going to be our pads, pad 1, 2, 3, and 4. Then if we push this to a 3D PCB, we're going to allow it to push everything. What we're going to end up with is the basic circuit board based on that rectangular profile. And this is going to bring in the 3D model of the push button that we created. And again, as I mentioned, it brings in some extra stuff. These are going to be the copper pads on the top. It's going to bring in the lines from our silk screen. So you can see that we've got 1, 2, 3, 4, and those lines at top and bottom. Those are going to be part of that layer 21. So anything you put on layer 21 is going to be silk screen for the top. 25 is generally the names. That can be turned on and off for silk screen, but usually it's omitted. So that's a basic idea behind creating your own component. Obviously, there's more to it. It's a pretty big topic, something that we really aren't going to dive super deep into. But this should hopefully give you enough information to be able to build or add your own. The next thing that we want to do is understand how to fix some of these components. For example, the joystick. The joystick already has its symbol. It already has its footprint to be used on the PCB, but the 3D model is a placeholder. Now, the reason for that is because, again, that's auto-generated. And what happens whenever you create a component library, for example, if we take a look here, any of the 3D components need to be stored as 3D models in the library to be able to be used as those 3D packages. So when you start to export libraries, if you build a library and you export it and it had a 3D package with it, it's very possible that that's no longer managed and it's just removed. So what you need to do is be able to place those items back into it. So what we're going to do is make sure that you do upload those 3 components, the push button, the cutie pie, and the joystick, and we're going to walk through the process of adding the joystick model. So in order to do this, we're going to go into our packages. We're going to go to joystick and double click on it. And you can see that this package isn't found in the current team hub. If it exists in library.io, we could import it, or we can bring it in from our current team library. So I'm going to save it as joystick. And you can see that it built out this joystick component. Now, the way in which I do this, I don't necessarily know if this is the best or the correct way to do it. There are ways to bring in step files. There are ways to manage this online. Generally, it's much easier if you build it from scratch and you build the model or you use geometry that you have by importing a step file. But if you have a 3D model in Fusion, so for example, this 512, you are able to drag it and drop it in, and then we can position it. I'm going to rotate this around underneath. If you want to position it precisely, you can do that by using things like align. And notice that with this 3D model, as we move this around, it doesn't align perfectly. You can see that some of the pins for the push buttons are off, some of the pins here are off, and some of those are off. Now, this is a problem that happens whenever you download a 3D model. You need to validate whether or not the footprint you're using, the thing that ends up creating the holes or creating the pads on your PCB, matches the physical model that you're using. As we've already seen with this joystick model, the joystick plastic part itself does not match the physical part that we're using that came from Adafruit or DigiKey. So that's something that you have to be really careful with. The biggest thing that you want is to validate whether or not the footprint is correct. Now, this is one benefit of using things like Adafruit, because the joystick that we ordered, the one that has the little breakout board on it, that breakout board is actually available from the data sets and from the documentation on the Adafruit website. What that means is you can download that board and the associated pad and footprint layout that you're using, which is actually where some of this comes from. But now that we have this built in, you see that it's got an external link. If you right click, you can break the link, which means that it no longer has that external reference, and we can select finish and save it. So essentially what we did is we cheated bringing in that 3D model. We're going to save it here. And then we're going to go back to our joystick package here and just make sure that it appears here. What that means is any library that's using this, if we go back to our controller here, if we go back to, let's say, maybe right here and to our library, we can update design from library. So for example, if we've got a library that we're using, lead controller team, and select update, if there's a new variation of this, it'll allow us to update that, and we can save our controller. And then we should be able to push those 3D models into our design. If we take a look at the 3D package, I take that back. We need to go to here, and we need to push to 3D and push that in. Sometimes there is a bit of a delay, and if you are using a local library versus a Teams library, then obviously this process changes a bit. But the basic premise here is that we're working in a Teams library here. We updated that Teams library by adding that joystick component. And then what we did was we updated our design based on a change to the library, and we pushed it all the way through from the PCB and into the 3D model. So this process is exactly the same for the Cutie Pie model that's provided, as well as the tactile push button. And if you want some practice, you can go ahead and do that. You can see that we actually have a pretty detailed push button here. This is very similar to the one that we built. And you can also see a lot of the other components. Once again, the Cutie Pie model here, this was downloaded directly from Adafruit, which is again a huge benefit. By working with them, they build a lot of these boards in Eagle or Fusion 360 PCB, so they're native files, and you can actually grab this and bring it directly in and use it. So that's the basic process. Hopefully that works for you. Hopefully you are able to do this on your own. If you do have any questions on this process, which I know this was a lengthy video, it's kind of why I wanted to do it at the end and not bog you down with these details midway through creating your own designs. But leave those comments here. I'll make sure that comments are turned on for this page. I'm actually going to make this video public because I know that this is a big question that a lot of people have. So I want to make sure that everybody has access to it. Even if they don't directly have access to download these data sets, they'll be able to at least follow along. So hopefully that was helpful. If you have any questions on this or if you had any problems along the way, please let me know. Libraries inside of the electronics workspace are really tough. It's a big topic and something that really you should be able to do, but you don't necessarily have to do on a daily basis. So make sure that you do play around. Don't worry about breaking any of these files. You can always go back and re-upload the library that was provided and play around with all these data sets. So hopefully that gives you enough information to create your own designs. If you do want to share those designs, I would love to see them at some point. Maybe we'll do a review video if anybody's created their own. We can go ahead and share those with everybody else. Not necessarily the circuit boards, but just images of what you've created. So thanks for watching. We really appreciate everybody who joins these courses. If you want to see anything else, if there's a specific course that you want us to create, leave some comments and let us know, or send us an email, support@learneverythingaboutdesign.com. So we appreciate it. Thanks so much, and we'll see you in the next course.